Welcome to Exploring Mathematics 2. In this video we're going to look at the problem of connecting four towns which are situated on the vertices of a 10 kilometre by 10 kilometre square. Okay, and we've got to connect them with electric cable, the minimum amount possible, so that electricity can flow from any town to any other. All right, now I'll just get you started on thinking about this, and then you would be encouraged to pause the video and have a go yourself, maybe make a few copies of this and try some ideas out. But the most obvious starting one, which everyone would probably try first, is just simply connecting A to B, B to C, or B to D, and D to C like that. You don't need the fourth one. You don't need this connection, because if that was electric cable, then any of those towns could receive electricity from any of the others, because they're all linked together, you see. And that's 30 kilometers, clearly, 3 lots of 10. Okay, so that's the first try. So you may want to pause now and try some more ideas for yourself. I'm now going to go on to the next idea that people try, which is a bit less cable than 30 kilometers. Okay, so we're now looking at a second idea, and that is to do this. Across there and diagonally across the other way as well. Okay, and they connect together in the middle of the square where they cross over. Okay. So that's the idea. That does use slightly less cable. If you're familiar with Pythagoras Theorem, you could work out the actual length of that cable there. So the length involved there is going to be, well, this is 10, you see, and this is 10. So the diagonal of a triangle with two short sides of 10 is root of 10 squared plus 10 squared, okay, which is the square root of 200, okay, and the square root of 200 is the same as the square root of 100 times the square root of 2, which is equal to 10 root 2, okay, but the total length is, that's 10 root 2, and then there's another one there also of 10 root 2, so it's 20 root 2, okay, so 20 root 2 and 20 times root 2 is equal to approximately 28.2 kilometers. Okay, I'll put there approximately equal because I've rounded it. Okay, so 28.2 kilometers. So it's slightly shorter, but it's not the shortest. Okay, now the next idea that is often tried is to, let me just underline these answers so far. Okay, the next idea that's often tried is to come halfway down. So you sort of would go like this. Okay, you connect A and B, you connect C and D, and maybe have a line down here like this. But of course, it's still 30 kilometers, the same as the first one, if you look at the 3 lines you've got there. So that doesn't save anything at all. So that's back to 30 kilometers. Okay. And then some people explore this with curves. And they think, well, I could curve this off a bit. Okay. And that might make it easier or shorter. Well, it doesn't work, because if you think about it, any curve that you might draw is always going to be shortened if you do a straight line instead. Okay, so that curve and that curve are obviously longer than they would be if they were straight lines. But then this across here could be a straight line connecting at the minimum point. Now, at this point, we're close to the correct solution. Okay, and it's really interesting. So if you still haven't found it yourself, it's leading towards it here. Pause the video and have a go, then come back and we'll go on to the next screen. Okay, so hopefully you're ready to move on now and look at the final solution to the problem. So we'll go on to the next screen and we'll be building on this one at the bottom right here that we looked at just now. So I've made a copy of the four towns with the dots a bit further apart, and I'm going to sketch in what we think the best solution would look like. So I'm going to take four lines that come in at this sort of angle towards the center, okay, but not towards the center, but on the way towards the center, if you see what I mean, a bit like that. And then we're going to connect the two sort of points there and there. We're going to connect those 2 points together with another piece of cable, and that gives us the shape that we're expecting to give the shortest possible cable length. So what I'm going to do now is put some measurements on that, and we're just going to I'll just make it a dashed line there and there in a different color. So basically this is just forming a right-angled triangle against one of those sloping lines. So all four of those red sloping lines are the same length and angles, okay, but we're just going to look at one of them, and I'm going to call this length here across here, we'll call this length X, and we know that this is 5 because it's half the distance between the two towns. So this is X, and this line here is what you get left over when you start with 10 and take away 2 lots of X. Okay, there's one and the other one's over here. Okay, so what I'm going to do next is work out the length of this sloping line H, okay, because my total cable is going to be 4 lots of H plus 10 minus 2X. So starting up here, I'm going to say that H equals the square root of X squared plus 5 squared. Okay, I'm not actually going to work it out any more than that at the moment, because I'm going to just say therefore total cable and I'm going to call this value Y, total cable Y equals, and it's going to be 4 lots of this thing here, okay, and I'm going to write that as X squared plus 25, but instead of writing a square root symbol, I'm going to put it to the power of a half, okay, and then add the 10 minus 2x as well, which is the bit in the middle. Okay, now I'm going to do that because we're going to now apply calculus to this. We're going to differentiate this expression here to find where it becomes a minimum. In other words, what value of x causes this expression to be as small as possible. So this is an A-level process. So I'm going to call that y. So this is dy by dx, and this is how we do it. Okay, dy by dx is what we call the gradient function, or the rate of change, and that's given by 4 times. Now I take this bracket, put the power in front and reduce it by 1. So it becomes 4 times a half of x squared plus 25 to the power of negative a half, and I multiply it by the differential of the bracket, which is 2x. Now this is called the chain rule, or the function of a function rule, okay, which you learn about in A-level mathematics. And I've also got to do from that the derivative of 10 is 0 and the derivative of minus 2x is minus 2, so I'm just left with that. And to find the minimum value of x, we need to set the rate of change of x to 0, which I do by just putting that there. Now, if I tidy up this bracket, I've got 4 times a half is 2 times 2x. So that means that 4x times x squared plus 25 to the power of minus a half, okay, is equal to minus 2. Equal to 2, I should say, because I'm adding the 2 to both sides. Okay, now what I'm going to do now is rewrite that as a square root, and you'll see what is going to happen. And that's going to be that 4x, and because it's to the power of minus a half, that's the same as dividing it by the same bracket to the power of a half, or the square root. Okay, so I'm just going to put that under a square root sign in a moment. So I've got x squared plus 25 under there with a square root sign around it, like that. And that is equal to 2. If I now multiply both sides by the denominator of that, I get 4x equals 2 times that square root. So 2 times this here. And if I take that to the next stage, I'm going to now actually square both sides. So I'm going to do 16x squared equals 4 times, and instead of the square root sign, I can just take that out, and that will give me x squared plus 25 without the square root sign, you see. Now I can multiply out that bracket. 16x squared equals 4x squared plus 100. Subtract 4x squared from both sides. 12x squared equals 100. Okay, now I can divide both sides by 12, or better still, I can divide by let me just go underneath again. I can divide by 4 to give me 3x squared equals 25, and that gives me that x squared is 25 thirds, and therefore x is the square root of that, which is 5 over the square root of 3, okay, because I'm square rooting the 25, and that's also written as 5 times root 3 over 3. We normally write it like that with the square root on the top. So that's telling me the value of x that causes the length of all the cabling to be the minimum. All right. Now I could work that out as a decimal, and or I could just leave it like that, and that's a better idea. So what I'm going to do over here is I'll just do this in a different color. So the total length of y now is the total length of cable, which is 4 times the square root of, now it's x squared, which is this thing I've just worked out squared, which I've written there as 25 over 3. So I can go straight to putting the x squared as 25 over 3. Okay. And I've also got to add another 25 to that. Okay, so it's 4 lots of that plus 10. Okay, plus 10 and minus 2 lots of x, which is 2 lots of 5 root 3 over 5. Now it's, sorry, over 3. Now it's always better to use the exact values in the calculator. You can always do the rounding at the end. Now if you do put that in the calculator carefully, you get that y equals 10 plus 10 root 3. Okay, now if you decimalize that, and you can say that that equals 27.3 to 2 kilometers to 3 significant figures. Now if you remember on the previous screen, the shortest we got was 28.2, and that was when the 2, we just simply had a cross going from A to D and B to C, but that is slightly less, as you can see. All right, so that's the answer to the actual problem. And just another point of interest here before we finish, you can work out the angle in here using a bit of simple trigonometry. All right, so if I wanted to know what this angle theta here is, okay, let me just do this over here. I can say that the tan of theta, okay, is the opposite over the adjacent, which is 5 over x, which is 5 over this thing here, right? Now you've got a fraction within a fraction, but we'll deal with that in a moment. 5 root 3 over 3, with a bracket round that bottom part. Okay, now when you divide by a fraction, you invert the fraction and multiply. So it's 5 times 3, okay, 5 times 3 over 5 root 3. Okay, the 5's cancel out to leave you with 3 divided by root 3, which is simply root 3. Okay, now that's the tangent of the angle, which is the opposite over the adjacent. Now theta, the angle itself, is the inverse tangent of root 3, and that's a well-known result, which you may know how to show that, but if you didn't, you could use a calculator and you would see that tan to the minus 1 of root 3 is exactly 60 degrees. Okay, and that's the angle theta. So it means the total angle between each of these is actually 120 degrees. All right, and that's the angle that causes the shortest total length of electric cable. All right, so all 3 of these angles around here are 120 degrees, and around there as well. Okay, so that's just an extra piece of information to add. Now you can explore this with 5 towns or 6 towns, and you'll find that the optimum route or the shortest distances can always be achieved with having these junctions where 3 lines meet at 120 degrees. Okay, so it's quite an interesting little problem, and there's the answer to the actual question there. As I said, that's slightly less than what we had in our previous trials earlier, and you won't be able to get it any shorter than that distance. Okay, that's it.